Welcome back, ladies and gentlemen, to question number 4 on the 2015 Canadian Senior paper. So it's a very short-looking question number 4. Determine all values of x for which, and then we've got this expression here, 2 times 4 to the x squared minus 3x all squared is equal to 2 to the power of x minus 1. Okay. So not a whole lot we can do. What we're going to eventually do is we're going to use a whole bunch of those laws that we learned for exponents. So things like if you have the same base and different exponents, if you multiply those expressions, the exponents add and the base stays where it is. I notice when I look at this, I've got a lot of 2's and 4's. We recognize 4 is 2 to the power of 2. 4 is a lot of things. It's 2 times 2, it's 2 plus 2. But in this case, since we've got a lot of exponents, we want to think of 4 as 2 to the exponent 2. Okay. And what we're going to do is we're going to use our exponent laws and simplify this expression on the left side to be 2 to the something. And it'll probably involve x's. I've got a bunch of x's over here. We'll have 2 to the something involving x is equal to 2 to the other something involving x. And the only way that can happen is if both of the exponents, both of the expressions in x are equal. So at that point, we can just talk about both of those expressions being equal, and hopefully we'll be able to solve for the value of x. I'm thinking there'll be 2 of them, just because I see this quadratic expression in x here. I'm willing to be wrong. Maybe there's only 1, but I'm guessing there's going to be 2. Okay. So once we've identified that we're going to have to use exponent laws, it's probably a good idea to try and remember some of them. So for example, if we have the same base here, and we multiply these 2 expressions, we add the exponents. So that's a good one. If I have something to another exponent and then I raise all that to another exponent, that's the same as if I just multiplied those exponents in. These are the 2 really important ones. There's some more, and if I need them, I'll write them down. But what have we got? We've got 2 times 4x squared, I think it was minus 3x, I'll go back and check in a moment, squared is equal to 2x minus 1. Okay, this is what we've got. So let's just double check. Yep, minus 3x. We're all good. So the first thing I'm going to do is I want to be able to use these laws. I want to have everything as a common base. I'm going to rewrite 2 as 2 to the 1. I'm going to rewrite 4 as 2 to the 2. And that's all being raised to the x squared minus 3x. And all of that is being squared. And that's just the same as 2 to the x minus 1. That's what we're told. Okay. Well, I see right here, which I'll mark in blue, I guess, I've got something to the power all raised to another power. And that's this second rule right here. So I can rewrite this, keeping everything the same, as 2 to the 2 times x squared minus 3x. And all of that's squared. Okay. We could expand this out if we wanted to. So let's do that. 2 to the 1 stays where it is. Then we've got 2 to the 2x squared minus 6x. All of that squared. Now inside the brackets, I've got 2 to a power times 2 to a power. Well, that's this first rule here. It says we can add these 2. So we really just add 1. We've got 2 to the 2x squared minus 6x plus 1. All of that's being squared, and that's the same as 2 to the x minus 1. Now, finally, in our last act of simplifying the the left-hand side, we've got 2 to the something. All of that's to the something. That was that second rule once again, and we multiply by 2. So we'll get 4x squared minus 12x plus 2. Just multiplying this 2 up here with this expression in x in the exponent. We multiply the exponents. So this is only true if the exponents are equal. We've got the same base. So this expression can only work if the exponents happen to be equal. Okay, another way to see this, if you know about them, logarithms would be fine. So usually if we have an equal sign in an expression, if we do something to one side and we do the same thing to the other side, you get to keep the equal sign there. So we could either say, well, this just always works as long as the expressions are equal, as long as the exponents are equal, or you could say, I'm going to apply log base 2 of both sides. Okay? Logarithms are designed to cancel out exponents. And so if you do log base 2 to one side and log base 2 to the other side, what that in effect does is it brings the exponents down, and you just get to talk about the exponents. So if you're aware of that, that's a step you could write in. I'm not going to, because not everyone who's writing this contest will have heard of logarithms. But if you have, and you were thinking that that's a good step, you're absolutely right. Okay, let's get back to the question. Okay, so the exponents have to be equal, and that means that 4x squared minus 12x plus 2 has got to be equal to x minus 1. Okay, well now we have a nice simple quadratic. So let's bring some stuff over. We got a minus 13x here, and the minus 1 becomes a plus 1, so we get plus 3. Alright. You can try to factor that out, I guess. Is there anything you could... I think... Okay, so we can either break it up into a 4x and a 1x, and then we have to break up the 3 in some way here. It'll probably be with minus signs. Or we would have to do 2x and 2x. Okay? But the 2x's, sorry, one of these should be a 1 or something. But the 2x's, if I combine them with 3's, I need to add up to 13. There's no way 2 times 3, that's 6, and then 2 times the other one, that's 8. We're not going to get anywhere close. So it's got to be a 4-1 split if it's going to be a nice split at all. So it's got to be 4, and the 4 is going to have to multiply with the 3. Okay, otherwise, you're not going to, that's going to make 12, and then what's left over, you're going to have a 1. And it's minus 13 we're going for, so this should be a minus 3 and then a minus 1. Okay. You could have also, I say this just about every time I go ahead and factor, you could have done a quadratic formula, and that would have gotten it no hesitation, no tricks, nothing like that. To factor it, you're sort of relying on the fact that they're going to give you nice numbers and that it will factor. Quadratic formula says the quadratic formula works no matter what you're doing. So it's usually the better way to do it. Okay. So the only way this is true is if at least one of the factors is 0. Okay, try and think about any two numbers being multiplied to be equal to 0. One of those numbers has to be 0 at least. Okay. So this first one, we bring the 1 over to one side, so 4x is equal to 1, or x is equal to 1/4. And over here, we're going to get x is equal to 3. So these are our answers, and if you wanted to, you could double check. What happens when I plug in 3 onto the left side exponent? I'll get 4 times 9, which is 36, minus 12 times 3, which is 36. So 36 minus 36 is 0, plus 2. So it's going to be a 2 in that exponent, and a 3 minus 1, that's going to be a 2 in that exponent. So we're going to get 4 equals 4. How about a quarter? With a quarter, you'll get, so here you get 2 to the, so x equals 3 gives 2 to the 2. And x equals a quarter, you will get 2 to the minus 3/4 over here. 4 times a quarter squared, well, the 4 and one of the quarters are going to cancel out. You'll just get a quarter. Minus 12 times a quarter, that's minus 3. So 1/4 minus 3, that's negative 2 3/4. Plus 2, that's just negative 3/4. So it does work. Did they ask for the x values, or did they just ask for how many? Okay, determine all x values. So x equals 3 and x equals 4, or sorry, 1/4. only values that work. Okay? We've explained ourselves. We have our exponent laws on display. We use them to argue down to this point where we've got the same base on either side. And that's only true if the exponents are equal, or apply logarithms if you know them. And that gets us a nice simple quadratic. Factor it, get our answers. We double checked. We didn't have to, because it's just a final answer question. But we did, because we got the time on this video, and we got 3 1/4, and hopefully that's what you got as well. So we're going to flip the page in anticipation of our next question, which is question number 5. We're going to get into that in the next video. Thank you guys for watching, and I'll see you next time.